Good morning, students. Today we are going to discuss the new topic on electrostatic potential at a point due to dipole. So, electrostatic potential at a point due to dipole. So, due to the dipole, what is the potential in a particular point? That is the meaning. So, first of all, let me draw the diagram. So we have to place two equal and opposite charges so that it will constitute an electric dipole. So it is the two charges which are equal in magnitude and opposite in direction. So it is placed and there is a dipole with a separated with a distance of 2a. From here to the positive charge, the distance is a. From the midpoint of the dipole to the negative charge is another a. Totally we have 2a distance. We have to consider a point P over here. Now let's draw a line from the point P to the charge Q, positive charge Q, having the distance R1. And another distance, that is from point P to the negative charge, is R2. And the distance from point P to the midpoint of the dipole is R. So now let's say this is the place A and this is the B. Now we have to mark the angle. So the angle between T to O and A to B, that is theta. So if it is theta, obviously we know that this angle will be 180 minus theta, isn't it? So this is the simple schematic diagram to understand the electrostatic potential at a point P due to the dipole. So let me first of all calculate the electrostatic potential at point P due to the positive charge and then due to the negative charge. So finally we will calculate both the potential. So let me calculate the electrostatic potential at point P due to the positive charge and B. So the potential P due to positive charge is given by V equal to, we have the general formula, that is we know that 1 by 4 by epsilon naught Q by R. So here the distance is R1, we will write R1 over. So let me say this equation number 1. And similarly we have to find out the potential at point P due to the negative charge. So that is the potential at P due to negative charge. That is given by V equal to 1 by 4 by epsilon naught. Here the charge is minus sign, negative charge. So we have to write minus Q divided by R2. The distance is R2. So we will mark this minus over in front of this equation. So here. So the value will be V equal to minus 1 by 4 by epsilon naught Q by R2. So this is the equation number 2. So now electric potential at point P due to the dipole. So now let's say the total potential. Total potential. The total potential at point P due to dipole is given by V equal to 1 by 4 by epsilon naught Q by R1. Here this minus sign, so we write minus 1 by 4 by epsilon naught Q by R2. So this is the we added to potential due to the different charges. So now let's simplify this equation. We will take the common factor outside. We will have Q by 4 by epsilon naught. So this is the common factor Q by 4 by epsilon naught. So once we take it outside, we will have 1 by R1 minus 1 by R2 inside. So this is the equation number 3. Suppose if the point P, look at the diagram, if the point P is located very far away from the dipole, this dipole is here, so the distance is 2a, we know that. By comparing with the distance of point P, if the point P is located far away, then it becomes maximum. The distance is maximum between the point P to the charge, isn't it? Whereas comparing with the dipole distance. So we can write this equation in terms of R. So by using the law of cosine law, we can write the equation. If suppose this is the suppose R is very greater than A. So we can write this equation in terms of cosine law by using law of cosine. Law of cosine. We can write R square is equal to the R1 square or R square plus A square minus 2RA cos theta. So it comes by using taking the cosine law in the triangle POB. So in this triangle, so like in this portion, if we take the law, we use the law of cosine, we will take this equation as R1 square is equal to R square plus A square minus 2RA cos theta. Isn't it? Now let's simplify this equation. So now R1 square, let's take this R square outside of this equation. We will have R square outside. Now let's see, if we take the R1, R square outside, what will be there? 1, isn't it? So 1 plus A square divided by R square, right? So if we take the R square outside, in the denominator, in this term, denominator we will write R square. So 1 we multiply with this, so R square is R square, A square divided by R square will get cancelled. Then the equation will be equal. So now let's see 2RA divided by R square cos theta. Now let's see this R square will get cancelled. Now R square 1 plus A square by R square minus 2A just look at this equation. 1 plus a square by r square minus 2a divided by r cos theta. So now we know that since the r square, the point is very far away from the dipole. So it means the dipole distance is very small. So for that we can neglect this equation, this term. So when we compare with the distance between the point to the dipole to the charge, if it is maximum, then the dipole distance is very minimum. So for that we can neglect this term a square by r square. So now we can write r square. So let's see the r is very greater than a. We can neglect the term a square by r. So 1 minus 2a by r cos theta. So this will be the equation. Now from this equation, just cancel this square. Let's see what happens. R1. So right hand side also we have to cancel this. So R1, R square will be R. Now 1 minus 2a by r cos theta in power we will have 1 by 2. Right? Because cancelling this square, we have to take a root over, right? Now let us inverse these equations. So let's say 1 by r1. So now it will be 1 by r. So now it will be 1 minus 2a by r cos theta
minus 1 by 2.
Right? Okay. 1 by r1 will be 1 by r becomes 1 plus a by r cos theta. So this is the equation after reducing this by using the binomial expansion. In this triangle, A, P, O, so in this triangle, similarly, we can find out the value for 1 by R2, that is 1 by R2 divided by R1, 1 by R, that is 1 minus A by R cos theta. So this is the equation number 4. And just keep it as a pi. So this equation is from the triangle AOP. Same procedure we have to follow, and finally we will arrive at the equation 1 by r2, that is equal to 1 by r 1 minus a by r cos theta. Okay. Now let's substitute using this equation number 3. We are going to substitute the value of 1 by r1 and 1 by r2 in this equation. So let's substitute. V equal to, what is the value? What is the equation? Q by 4 by epsilon naught. So in place of 1 by r1, we will write 1. And now minus, right? This is 1 by r, 1 minus a by r cos theta. So let's say this is the q by 4 by epsilon naught. This 1 by r, here also 1 by r. Can we take it outside? So let's say this is the 1 by r. R has keep outside of this equation. Yes, right? plus A by R cos theta minus 1 minus plus A by R cos theta. Right? Let's say V equal to, see, 1 plus 1 minus 1, A cancel, isn't it? A by R cos theta, A by R cos theta, totally 2 A by R cos theta, right? So 1 by 4 pi epsilon naught Q by R, here it is 2 A by R cos theta. So this is the value. Now we know that the dipole moment, isn't it? Electric dipole moment. Already I mentioned electric dipole moment, that is P equal to 2QA. So can we compare this dipole electric dipole moment? So P is equal to 2QA. Alright, 2A. So let's see. Here it is 2A and there is a Q also. So by replacing by removing 2A this Q, we will put P. P cos theta by R. Right? This equation in terms of vector form. So we can write V equal to 1 by 4 by epsilon naught P vector can be written as P vector into R cap divided by R. So now, by applying the special cases, let's say if the P lies on the positive charge, we will have a equation as, let's say, see, if suppose P lies on the positive charge, Q, then the theta value will be how much? Theta value will be 0, right? If the point is on the positive charge, the theta value will be 0. Now let's say cos 0 is what? By applying this 0 value in this equation, final equation, so we write V equal to 1 by 4 pi epsilon naught P cos theta divided by R, right? So applying this theta value in this cos theta. So now let's say cos 0 is how much? Cos 0 is 1, right? So now we can say the potential at point P due to the positive charge will be 1 by 4 pi epsilon naught P by R, because 1 will not give any changes. So same as it is. Now second case, if suppose P lies on the side of negative charge, on the side of negative charge, P lies on negative charge, then the theta value will be 180, isn't it? 180. 180 is cos 180 is how much? Cos 180 will be minus 1. Right? So now the value will become P is equal to minus 1 by 4 pi epsilon naught P by R. Isn't it? Now the third case, P lies line of dipole. The value will be 90 degrees. How much? These are the three special cases which are very important. We calculated electrostatic potential at a point due to electric dipole. So it's It's very important topic. So thank you.